All right, hey everybody. So this is the last video, I believe, that we're going to have for sentential derivations. I'll post some practice problem answers so you can go through those. But for this last one, I wanted to go through section 10 of the slideshow 16 called Strategies and Tips. And this is supposed to give you some ideas about how to attack proofs when you aren't quite sure exactly what to do. So the first set of strategies are going to be strategies we call based on show lines. That is, what your show line's main connective is gives you some advice about how you should sort of attack the derivation. And the first sort of advice is that if you have a show line where the main connective is an or, you should try indirect derivation. And that's because the assumption you get is especially useful in that case. And so let me give an example of that. So I'm going to write down the argument here. Suppose our premise is P or Q and P or R. And we want to show, what are we trying to show? P or Q and R. Okay, so as you'll see here, our main connective is an or, and so we're going to try to do indirect derivation. Remember, that allows us to assume the opposite here, so we assume not P or Q and R. So the whole thing negated. We assume that, and then try to show a contradiction. So why is that a good strategy here? Well, you can do a lot with this assumption. Our not or out rule allows us to get the negation of the first thing and the negation of the second thing, and that's going to be really useful. So let's see how that works here. So not or out tells us we get not P. It also tells us we get not Q and R. Okay, remember, we're just looking for any contradiction here. Doesn't matter what contradiction it is. We're looking for a formula and its negation. So let's think about how this might go. First, we can break down line 1. So we can get each of those separate because it's an and. So we get P or Q from line 1 by and out. And we get P or R from line 1 by and out. Now we're getting somewhere. Notice now that line 5 and 7 allows us to derive Q from or out. And then using line 5, not P again, with line 8 now allows us to derive R, also by or out. So that comes from line 5 and 8 by or out. I've run out of board space here, so I'm going to move over to the other side over here, but your proof should sort of just continue in one long line. So after this now, we've almost got a contradiction because we've got Q and R, and we've got not Q and R. So we just need to put this together. So on line 11, I'm going to write down Q and R. Right there, that comes from lines 9 and 10 by and in. And now it's probably a little hard to see because we're not all in a row here, but we've got a contradiction. We've got Q and R there, and we've got not Q and R there. And that's a contradiction, so we can write down that funny X, and then cite the line numbers 6 and 11 by contradiction in. So now we just need to finish up our proof. We write DD here, because what we were trying to show is at the bottom of our proof, and we box that. So it's going to go down here and then continue all the way down to here. And then we write ID here, because it was an indirect derivation, and box all the way down. So that's an example of what we call the one strategy based on a show line. If you've got an or in your show line, you want to try to do indirect derivation. A couple of other pieces of advice we can give, depending on the show line, and I won't work through examples for this one, I'll just sort of describe the advice. Suppose you have a show line whose main connective is an and. So you've got something like this. Show A and B for some A and B. Well, then the best approach here is to first try to show A. Hopefully you can do that. Then try to show B. Hopefully you can do that. And then at the end, put A and B together by appealing to both of these lines. So you sort of break your proof in half. That's not always necessary when you have an and, but it's something that will always work if you're feeling stuck. One more strategy based on a show line, and it's going to look very similar to this. Suppose what you're trying to show is a biconditional. It's the double arrow. Well, if you're trying to show that, what you want to do is first show A arrow B, do conditional derivation, that is, assume A, and then show B. After that, try to show B arrow A, assume B, and show A. And then when you've done all that, put it together with biconditional in to get A biconditional B, appealing to this line and that line. So those are three different strategies that sort of tell you what to do based on what's in your show line. And I've sort of summarized this on a little table in the slideshow on page 61. All right, you'll next see some practice problems on the slideshow. I'm not going to go through those right now. I'm going to post those just to our Moodle site so you can look through those on your own. But I wanted to talk about a couple of other strategies that are not based on show lines here. Strategies that can help you solve some of the trickier proofs you might encounter. So that's going to be the last thing we do here. The first, there's two strategies in particular. The first we're going to call the wedge out strategy. And the basic idea behind this strategy is that suppose you're stuck in a proof, but you have an available line whose main connective is a disjunction, an or claim, and you haven't been able to use that yet. This strategy is going to tell you what to do in that case. So let's walk through an example. Suppose your premise is this. If P, then Q, or if P, then R. And you're trying to show if P and not Q, then R. Okay. So we know how to set this up first. It's a conditional in our show line, so we're going to do conditional derivation. We're going to assume the antecedent and try to show the consequence. Oops, R. Okay, but at this point you might be feeling a little bit stuck. And the reason you might be feeling stuck is that there's not much you can do here to get R, and there's nothing you can do here to get rid of that disjunction, that or claim. So what this strategy says is, look, you've got an or claim, premise one, that you haven't been able to use. And the strategy says, try to show the negation of one of the parts. If you're successful, you can then do or out. So that's what I'm going to do. I'm going to try to show not P arrow Q. Because I know that if I do show that, I can then use it to do or out and get P arrow R, which will help me get R. That's the basic idea here. How am I going to show not P arrow Q? Now notice I cannot do conditional derivation because the main connective is not a conditional, it's a negation. But I can do indirect derivation. So I'm going to set that up by assuming the opposite, P arrow Q, and trying to show a contradiction. Okay, can we do it? Yeah, we can. First, we're going to break apart line 3. So we're going to get P, and we're going to get not Q. Those both come from line 3 by and out. And now P and P arrow Q gives us Q. That's 6 and 8 by arrow out. And now we've got our contradiction, Q and not Q. That comes from 9 and 10 by contradiction in. Okay. What happens now? Well, we've shown the contradiction. So we box and cancel. And now we've shown not P arrow Q, because we showed that the assumption that it was false led to a contradiction. So that's an indirect derivation. Now we're not done though. We haven't yet shown R. We've just shown this intermediate step. But that's now useful, and it's something we can appeal to. Remember, everything in the box is off limits, but we can still appeal to line 5 here. Because we've shown it, it's canceled. And so line 5 and line 1, by OR out, now allow us to derive P arrow R. I'm going to go ahead and go to the other side because I've kind of run out of room here, but you'd want to continue down below. So line 12, outside of this box now, we're going to get P arrow R. That comes from lines 5 and 1 by OR out. Okay? Now what are we trying to get? We're still trying to show this R here, but now we should be able to do it. We can use this P, once we break it apart, and this arrow to get R. Notice we can't appeal to this P because it's inside of a box. We're going to have to get it again from line 3. So there we go, from and out. And then we can derive R from 12 and 13 by arrow out. Okay, so where are we? Well, we were trying to show R. R is at the bottom of our proof, so that's a direct derivation. So we're going to cancel and box everything all the way down to the bottom. And what kind of proof was this? What kind of derivation? Well, it's a conditional. Assuming the antecedent, we showed the consequent. So we cancel and box everything all the way down to the bottom there. And that's the completed proof. Notice again, the key step was right here. We were stuck, but we had an available line that had an OR, and so we tried to show the negation of one of the sides, and that's what allowed us to finish the proof. Okay, one more kind of strategy like this I want to show you, and then that will be it for sentential derivations. This we call the arrow out strategy. And it's similar to the strategy we just saw here. The basic idea is this. If you're in a proof and you're stuck, but you've got a conditional, an if-then statement as an available line you haven't been able to use, try to show either the antecedent or the negation of the consequent, because then you'll be able to do arrow out and make use of that line, that conditional line you haven't been able to use. So let's give an example of how that works. Okay, so suppose your premise is this. P arrow R, arrow not P or Q, I believe. Yeah, that's our premise. And we're going to try to show if P and Q, then not R. Okay, first things first, we see that there's a conditional in our show line. Right away we should think conditional derivation. So we get to assume the antecedent, P and Q, and try to show the consequent, in this case not R. What should we do now? Well, we'd like to somehow use this conditional here. How could we use this conditional? Well, we could either get P arrow R, or we could get the negation of the consequent. We could get not P or Q. It's going to be easiest to try to get the negation of this. So let's see how that works. Well, we've already got P and Q, so we can get P by itself from line 3, by and out. Now by or in, we can get P or Q from line 5. And finally, we can double negate that to get not P or Q from line 6 by double negation. Okay? So look what we were able to do. We're able to get the negation of the consequent of the conditional. And that's good because now we can use it. So let's apply this. Arrow out says if you've got the negation of the consequent, you can get the negation of the antecedent. So we can get not P arrow R from lines 1 and 7 by arrow out. All right. Which rule are we going to use now? Well, if you look back at our new rules, the extra rules that are on that right-hand column, you'll see that we have a rule we called not arrow out. And it says the following. It says if you have a negated arrow, you can get this, P and not R. And that should be familiar. That's just the negation of an arrow. So line 8, not arrow out, gives us P and not R. And what were we trying to prove? Well, not R. And we've got it right there. We just have to get it by itself. That comes from line 9 by and out. And so we've directly derived not R, which means we've conditionally derived what we set out to show. And again, the key moment was right in this move here, where we decided we need to try to get something that would be useful to breaking down this conditional. So as you're working through these derivations, if you get stuck, I urge you to think sort of strategically. That is, if you've got some premises or some lines you haven't been able to use, try to show whatever you need to be able to use those. And those rule sheets hopefully can help you do this. All right, that's it.